Imagine a machine so tough, so simple, and so reliable that it has been called the Sky Jeep Willy. Right now, while the rest of the world is distracted by million-dollar plastic airplanes and flashy computer screens, the smartest mechanics on the planet are quietly hoarding every Cessna from the 1950s they can find. They aren't buying them for the leather seats or the cup holders. They are buying them because these are the last heavy metal survivors of a forgotten era of invincibility. In the 1950s, engineers did not use software. They used slide rules and raw intuition to build airframes that statistically refused to fail. But there is a dark shadow hanging over the hangars. A new government mandate and a shift in the global supply chain are making these legendary tractors of the sky nearly impossible to find. Why are the pros desperately grabbing these relics before they disappear forever? And what do they know about the future of flying that you don't? Line up a 1955 Cessna 170B next to anything built in the last 20 years, and the difference starts at your fingertips. Grab a caliper and run it across the rivet lines on a 170B wing, center to center. You will clock a spacing of exactly 1.5 inches. Not a hair more, not a hair less. Each of those rivets is solid aluminum, driven by hand, not some snap-fit miracle of modern assembly. The spacing is not just for show, it is a fatigue barrier, a signature of Wichita's old war plant discipline, hammered into every airframe by men and women who had just finished building B-24s. Now take a look at the skin. The gauge on the 170B's main wing panel measures a beefy 0.025 inches over half a millimeter of 2024 T3 aluminum, heat-treated and batch-aged in the original Cessna furnace. That is not marketing fluff. That is a real shield, the same alloy that armored World War II machines dominating the sky. Most modern trainers will give you 0.018, maybe 0.020 if you are lucky, and they call it an upgrade. But a law of physics never lies. Thicker skin means more energy absorbed in the impact zone, more time before you ever see structural collapse. That is not theory, that is physics, and it is the reason these old birds are still flying out of strips that would rattle a composite nose wheel into spare parts. Move down to the gear leg. On the 170B, you are holding a welded steel strut that tips the scale at 23 pounds. That is real mass, forged and heat-treated, designed to take a side load from a crosswind landing on a gravel bar and shrug it off like a steel tow boot. Compare that to a modern cast aluminum leg, lighter, sure, but with a wall thickness that would not pass muster in 1955. You want to know why the old-timers trust these machines? Because every ounce in that gear leg is a promise. You can land hard, you can land ugly, and the flying anvil will protect the meat inside. These are not just numbers on a spec sheet. They are the fingerprints of an era when every part had to earn its place. The proof is right there, under your caliper and in your hand. And that is just the beginning. Slide a caliper over the spar cap on a 170B and you are holding nearly 9/10 of a millimeter of 2024 T3 aluminum, 0.035 inches to be exact. That is not just a number, that is the difference between a spar that flexes and one that absorbs a lifetime of rough field abuse without flinching. The cap flanges stretch a full 1/4 inch across, forming a box so stout you would sooner bend a crowbar than see it buckle. Modern trainers are a different story. You will find spar caps barely thicker than a business card, optimized for weight and cost, not for the kind of punishment that comes from dropping into a gravel bar with a crosswind and a full load of gear. Now look at the seat rails. On the 170B, you are staring at a welded steel channel with a wall thickness of 0.070 inches, bolted directly to the bulkhead. No spot welded shortcuts, no stamped tin. These rails are double bent for torsional strength, designed so a working man can slam down after a long day and not worry about a cracked bracket sending him through the floor. Compare that to the thin-walled aluminum rails in a new Skyhawk. Lighter, sure, but one hard bounce and you are filing a service bulletin. The 170B seat rail is a relic from a time when engineers built with their hands, not just their spreadsheets. Set the old spar cap next to a modern one, and the heft is obvious. The 170B feels like a chunk of industrial history, forged in the same mindset that sent World War II machines dominating the sky. When you see the cross-section, you understand why mechanics hoard these parts, because a law of physics never lies. Mass in the right place buys you time in the impact zone. It is not nostalgia, it is survival. Every ounce of metal in these old airframes is a bet against structural collapse, a promise that when things get ugly, the flying anvil will protect the meat inside. There is a reason these numbers matter, and it is not just pride. The way this metal behaves under load, under shock, under decades of weather and work, that is the next piece of the story. The secret is not just what you measure, it is how a 1950s airframe takes a hit and keeps its promise. The heart of a 1955 Cessna 170B isn't just thicker metal, it's the DNA of wartime Wichita, stamped into every panel and bracket by hands that knew what it meant to build for survival. The men and women who riveted these birds together had just finished turning out B-24 Liberators, and they brought that same zero-shortcut discipline to the civilian line. You can trace it right down the alloy map, 2024 T3 for the upper and lower skins, the same high-strength aluminum that armored World War II machines and helped them dominate the sky. That's not some marketing badge, that's a metallurgist's pick, chosen for its fatigue resistance, its ability to take 1,000 cycles of flex and still hold form long after a modern composite would spiderweb and fail. Move inside, and you'll find 2014 T6 ribs and stringers, cold-formed and then heat-treated in the same batch furnaces that once soaked bomber spars. The 2014 alloy isn't just easier to shape, it's got a ductility that lets it absorb a hard landing and spring back instead of cracking. Every rib, every frame, is a deliberate choice. A craftsman's answer to the question, will this hold up when a gravel bar tries to bite? At the stress points, the story gets even better. 7 U75 T6 fittings, bar stock machined into control surface hinges, and spar attachments deliver a yield strength north of 70,000 psi. That's fighter plane metal, not trainer fluff. When a restorer pulls a bracket off a 170B, you can see the machining marks left by a toolmaker who knew his work would be tested by real-world abuse, not just a spreadsheet simulation. Ask any metallurgist worth his salt, and he'll tell you these weren't random parts off a shelf. Every alloy location pair was mapped for a reason, 2024 T3 where the skin takes the brunt, 2014 T where you need a little give, 7U75T where failure isn't an option, and all of it hand-fit on jigs that still bore the scars of military contracts. The result? A flying anvil, not a disposable drone. A law of physics never lies. Mass, margin, and metal in the right places buy you more than nostalgia. They buy you another chance in the impact zone, protecting the meat inside. That's the kind of lineage you can trust when the runway is nothing but rocks and hope. Step into the bones of a 1950s Cessna and you will find a story that starts long before the first rivet was set. Every panel, every bracket, every rib was born in a factory where heat treat was not just a checkbox, but a ritual. The metal of the 170B went into the furnace as raw stock and came out with a memory. Batch aged in a ton-sized oven, soaked at 1020 degrees for an hour straight. That is not a guess. That is the number stamped on the old batch log, and you can bet every mechanic worth his salt has seen the temper marks hiding under a layer of dust and time. But the real magic is what happened next. Before a single skin met daylight, it got a bath in zinc chromate primer, aviation's original armor. That greenish-yellow haze, sometimes called zincose in the old manuals, still clings to the inside of a 170B wing if you peel back a panel. It is not just for show. Zinc chromate is a chemical promise. It stops corrosion before it starts, sealing every seam and every rivet hole against the slow creep of moisture and time. Veteran mechanics will tell you, if it smells like zinc chromate, it will fly another 50 years. This was not penny-pinching production. This was the legacy of World War II machines dominating the sky, when every floatplane and bomber had to survive salt spray, mud, and a ground crew with a hammer for a toolkit. The old-timers called it over-engineering, but it was really a kind of blue-collar insurance. You built it heavy, you primed it thick, and you made sure every surface could take a punch from the elements and keep its promise in the impact zone. That is why you will find mechanics hoarding these old birds. Not because of nostalgia, but because a law of physics never lies. Primer buys you decades, heat treat buys you margin, and the culture that built these flying anvils believed in both. The zinc chromate finish is more than a color. It is a tagline for a lost era, built to survive, not just to sell. In a world of disposable drones, the old Cessna stands as an iron vault, still ready for the next storm, the next gravel bar, the next generation. Start with the cold numbers. FAA registry logs show the 170B fleet shrinking from over 1,100 active airframes in 2015 to barely 870 by 2023. That is a 24% drop in just 8 years. 1 out of every 4 Sky Jeeps is gone, either parted out or locked away in a hangar like gold in a safe. Meanwhile, auction listings have gone from make offer to blood sport. In 2021, a clean 170B fetched $115,000 if you were lucky. By spring 2024, that same bird cracks $150,000 without even a fresh annual. The rare ones, no corrosion, original logs, are pushing $200,000. That is not a bubble. That is the herd stampeding for the last real iron vaults left in the sky. On the ground, the panic is real. Walk the ramp at a backcountry fly-in, and you will spot the buyers, bush pilots in work boots, cash in hand, scouring for anything with a 1950s data plate. One A and P mechanic, sleeves rolled, eyes scanning the logbooks, mutters, "If you do not grab one now, forget it. They are turning into unicorns." He is not wrong. The FAA's new airworthiness directive gives 30 days to prove certified parts or face grounding, and owners are scrambling. The last supplier of 2020 series rivets just shuttered. Mechanics are stripping donor wings, hoarding hardware, swapping stories like wartime codebreakers. Every auction spike, every disappearing end number is a warning flare. The flying anvil is slipping away, and the world is not making any more. A law of physics never lies. When supply drops and demand spikes, the only thing left is regret and empty hangars. For those who understand what it means to trust metal over marketing, the clock is ticking. March 11th, 2025. An email lands in the inboxes of every A and P who still keeps a 2020 series rivet bin. The subject line read, "Final Notice. Discontinuation of certified airframe hardware. The last US supplier of original 1950s spec rivets, brackets, and spar hardware is shutting its doors." The message is blunt. Effective April 1st, no more production, no back orders, no exceptions. The reason is new. FAA documentation rules. Every part must now carry a traceable chain of custody from raw billet to shipping box, with a paper trail that would make a Pentagon auditor sweat. Traceable is the word that changes everything. The supplier's statement read, "Unable to comply with Airworthiness Directive 2024-2306, we regret to announce permanent closure." Permanent closure. Flip open the FAA policy binder, and there it is, black and white. All structural repairs on aircraft manufactured before 1970 must utilize certified traceable hardware. Non-compliance will result in immediate grounding under airworthiness. Directive 2024-2306, Clause B. 30 days. That is the window. After that, any Sky Jeep that cannot prove its parts pedigree sits on the ramp, wings clipped by paperwork instead of weather. Inside the hangar, the mood turns from quiet pride to crisis. Mechanics are stripping donor wings, hoarding hardware in Ziploc bags, trading old stock like wartime ration cards. Hoarding becomes the new work shift. You hear the phrase whispered after hours, "The last real iron vaults are slipping away." One old-timer scrawls it in grease pencil on a locker. A law of physics never lies, but the FAA sure can. Hangar quiet hangs heavy. The smell of zinc chromate and old avgas lingers, a reminder that every click of a 1950s door latch is another promise kept. But outside, the world of disposable drones marches on. The flying anvil is under siege, not by time, but by policy. The clock is running, and the survivors are the ones who act before the parts go dark. NTSB docket AAR20-0401. A Cessna 170B comes in hot, the left main catches a rock, the wing digs in, and there is a sickening crunch. But the cabin holds. The pilot walks away with a bruised ego and a bent prop, not a broken cockpit. Pull the accident sheet, no hull penetration, no structural collapse. That is not luck. That is metal doing its job. Case after case, you see the same pattern. The 170B absorbs the punch, spreads the load, and keeps the meat inside safe. Meanwhile, the same year, docket AAR20-07022, a late model 172 with lighter skin and composite fairings. Impact under 15G, but the right wing folds and the main spar punches through the floor. That is the difference between a flying anvil and a disposable drone. Bring in the lab numbers. The FAA pull test on a recovered 170B spar cap, dog-boned and strain-gauged, was pulled until it screamed. The curve does not lie, 46 KSI yield, 48 KSI ultimate. That is fighter plane territory, the same metal pedigree as World War II machines that once dominated the sky. A modern 172S rarely shows more than 33 KS1 before the aluminum gives up the ghost. The 170B cap takes a beating, bends, and only then gives way. That is what you want in the impact zone, a slow, controlled crush, not a brittle snap. Ask the DER with a stack of NTSB abstracts on his desk. He will tell you that a law of physics never lies. More mass in the right place buys you time, buys you options. The numbers back it up. 170B accident survivors outnumber 172s by a factor of 2 to 1 when the airframe gets tested. You can run the math, you can run the drop tests, but in the end, it is the metal that decides if you walk away. That is why the old hands hoard these airframes like gold. Because a flying anvil does not care about paperwork or planned obsolescence. It just keeps its promise. Drop a 1955 Cessna 170B and a modern Skyhawk into the same virtual crash simulation, and the truth comes out in slow motion. The 170B does not crumple, it absorbs, flexes, and spreads the force like a blacksmith's anvil taking a hammer blow. The forward spar buckles, but the cabin holds. In the simulation, the collapse takes time, a slow, grinding deformation that lets energy bleed away before it ever reaches the cockpit. The digital model shows a progressive crush zone, almost a cushion, stretching the impact over a third of a second. That is the difference between walking away and being carried out. Run the same scenario with a modern trainer and the numbers flip. Thin gauge skins, brittle composite fairings, and a stiffer, lighter box mean the structure snaps back hard and fast. The cabin floor folds, the firewall buckles, and the impact zone is measured in milliseconds, not fractions of a second. The data does not care about nostalgia. Peak G-load on the 170B was 15 G-forces. The Skyhawk was over 20 G-forces. That is not just a win for the old bird, that is the law of physics, never lies, stamped in aluminum and blood. This is where the metaphors hit home. The 170B is the flying anvil, heavy, slow to yield, always buying you time. The modern composite is the disposable drone. It looks good on a spreadsheet, but when the world turns ugly, it is the iron vault that keeps the meat inside safe. Ask any airframe and power plant mechanic who has stripped a wreck, the old Cessna folds with dignity, not panic. It is a promise made in the Wichita heat, back when World War II machines dominating the sky set the rules for what survives. The simulation ends, the dust settles, and the message is clear. If you want a chance in the impact zone, you want the Sky Jeep, not the drone. That is the kind of proof you cannot argue with. The last real iron vaults are fading, and the clock is ticking. Right now, every real mechanic knows you can't argue with the metal. A law of physics never lies. As the last flying anvils vanish into private hangars, the era of World War II machines dominating the sky is nearly over. Modern plastics crack. Legacy airframes shrug off impact. If you want to protect the meat inside, you better grab an iron vault before the doors click shut for good. Drop your thoughts below.